This is the Chapter 10 Lesson 2 video for significance tests and confidence intervals for two sample means. So here we're going to do a problem together to get you the idea of what we're trying to determine in this lesson. So it's the same idea as we did in Chapter 9, except for now we're looking if there's a significant difference between two sample means. So here we have two girls who've been playing basketball together since 5th grade that have always gone to school. They've been competitive, and Charisse thinks that she's the better offensive player. She thinks that 15-point average and with a standard deviation of 3.1 points this year, as opposed to Joanna's 12.5-point average with a standard deviation of 2.3 points. She thinks that that shows that she's the better offensive player over the 22 games they played this year. We're going to look for evidence that one's a better player. So we're going to do state, plan, do, conclude. So here are the state and plan portions if we're doing a significance test. We're going to do each portion for a significance test and talk about how it's different for a confidence interval. So state, we want to state what the question is. So we state our question of interest. We say we're testing the following hypotheses at the alpha equals 0.05 level. Use 0.05 if you're not given one. Remember, we can also use 0.01 or 0.1. And then we state the hypotheses. Our null hypothesis is the statement of no difference, that they're actually the same, and that by chance we got this sample. Our alternative is what Charisse thinks, that she's the better scorer. She wants to be able to reject this null hypothesis to show that it's not plausible, to show that she's the better scorer. And then we define what mu1 and mu2 equal. If we define these the other way, where Joanna's would be mu1 and Charisse's mu2, then our sign here on the alternative would be the opposite way. In the end, we'd get the same p-value. Things would just be switched around. If we're doing this for confidence interval, we're not going to have any hypotheses, and we're going to state the confidence level we'd be using. So since we're looking at a one-sided test, that corresponds to a 90% confidence interval. So our confidence interval, we're going to look at a 90% confidence interval for the true difference in average points scored. So plan, we're checking random, normal, and independent. Remember, random tells us center, and normal tells us the shape. Independent tells us the spread, or lets us use our standard deviation equation. So for random, we take the difference in the two means, is what the random that we would expect for the center. So we're going to treat the 22 games as an SRS, which is the best we can do with this case. We don't know if the population is normal, so we're not sure there if the normal condition is met. N is less than 30, so we would graph both original data sets, and if there are no outliers and no significant skew, the condition would be met. And here is the standard deviation of the difference. Remember, more variables, more variance. Although we're subtracting the two, variance is add. So calculate the test statistic. We're going to have our t statistic, because we don't know the true population standard deviation, and it's a sample mean, is going to be calculated like this, and we're going to use that to test. What I'd like you to do is go ahead and go to stat, tests, to sample t-test, input the information, where x bar 1's the average of Charisse, and all the ones represent SX1 is Charisse's standard deviation, and 1 would be 22, the number of games, and then all those same symbols with 2 would represent Joanna's. Our alternative would be greater than mu2. We're going to go pooled, no, and then calculate or draw to calculate the significance test and get your p-value. You're going to be concluding for the free response here, and then go to stat, tests, to sample t interval, to samp t int. It's 0 on your calculator, and input the same things to get a confidence, but your confidence level is going to be 0.9, and go ahead and calculate that. Please write two conclusions in the free response. One would be the significance test, whether you're going to reject the null hypothesis, the statement of no difference, or fail to reject, and why based on the p-value and significance level. And then explain the confidence interval for the true mean difference in their scoring. Now the multiple choice is about the difference between z and t. Remember, z is always used. We say zaptax because that helps us the most often. Z is always for proportion. T is for a sample mean when we don't know the population standard deviation, which is often true. Remember, for proportion, we determine that standard deviation based on the value of p from the formula we have on the formula sheet. But for a sample mean, we'd be using the standard deviation of our sample, our data set, and using that as an estimate of the true population. So we use the t-distribution since it changes based on sample size. And we know larger samples have less variability or less spread. So go ahead and do the conclude part for confidence interval and a significance test, and then the multiple choice question about t versus z.